Write a Raptor algorithm that analyzes file size of various files on a computer. The first input is the number of files to analyze. Each of the remaining inputs are the sizes of each file in megabytes. For example, the second input is the size of the first file, and the third input is the size of the second file, and so forth. Your algorithm will first output the number of files whose size is more than 50 megabytes. Next, your algorithm will output the average size in megabytes of all files. Finally, your algorithm will output the largest file size of all files analyzed. You may assume that the number of files in all the sizes input for each file is greater than 0. To develop a solution for this problem, we remember our 4 steps. First, understand the problem. Next, design an algorithm. Then, implement an algorithm in Raptor. And finally, test the algorithm. To better understand this problem, we return to the problem specification, where we find that we have an input which is supposed to be the number of files to analyze, followed by a series of inputs, which each is a file size. We also have 3 outputs. The first output is the number of files whose size is greater than 50 megabytes. The next output is the average size of all files, and the third output is the size of the largest file that was input. Designing our algorithm, we know that we need to start by getting an input from the user for the number of files to analyze. We'll store this input in a variable called num files. The next several steps will complete once per file entered. In other words, we'll do it num files times. We'll get the file size, and then we'll update our running total, which will help us calculate the average at the end of our loop. We will also check to see if the value input is greater than 50, and if so, we'll update our count of files greater than 50 megabytes. Lastly, we'll compare the file size with the largest of all file sizes that have been entered so far, and if the file size entered is larger than the largest ones we've seen so far, we'll update our largest file size. We conclude our algorithm by outputting 3 values. First, the number of files whose size is more than 50 megabytes. Next, we calculate and output the average of all file sizes entered. And finally, we output the largest of all file sizes entered. Implementing our algorithm in Raptor, we'll start by saving our file as homework 1-3. Our first symbol will be an input symbol, where we prompt the user to enter a number of files he wants to input, and we'll store the value in a variable called num files. Next, we add our loop structure, including assignment boxes, to initialize and modify our loop index variable. We'll initialize index to 1, and we modify index by increasing it by 1 at the end of every loop. Our loop test condition is index greater than num files, which is when we will exit the loop. With these symbols, we have our counted loop structure in place. Item, initialize, test, and modify. In the middle, we'll add steps to evaluate or execute based on the problem specification. Every time through the loop, we want to prompt the user for a new file size, which we'll store in a variable called file size. This achieves the first of several steps that we needed to execute inside of our loop. Next, we'll update our running total. For this, we need a variable to keep track of our running total, which we'll initialize to 0. Inside of the loop, we'll update this variable running total by increasing it the value of file size every time through the loop. And so we've completed the next of the several steps we needed to accomplish inside of the loop. Next, we'll update our count of file sizes greater than 50 megabytes. For this, we need another variable, which we'll call count larger than 50, and we'll initialize that variable to 0. Then, every time through the loop, after the user enters a file size, we'll check to see if his input was greater than 50. If it was greater than 50, we'll update count larger than 50 by increasing it by 1. With these changes, we've accomplished the next requirement of our loop, to update the count of files with size greater than 50. Our last step inside the loop is to update the max file size value. To do this, we'll need an additional variable which we'll call max file size. We'll initialize it to 0 to ensure that it's small enough that the value will be updated the first time through the loop. Then, every time through the loop, we'll check to see if the user input is greater than our current max file size. If it is, we'll update max file size to the value of the current input. With these changes, we've completed the last of our loop execution steps to update the max file size value. To complete our algorithm, we need 3 output symbols. The first output will be the count of files larger than 50. Before we can output the next value, we need to first calculate the average, which is the running total divided by the num files. Then we'll output the average, and finally we'll output the size of the largest file. These last several steps implement the final requirements of our algorithm. We are finally ready to test our algorithm, which we'll do with several test inputs. Our first test will be 3 files of sizes 36, 10, and 24, with expected outputs of 0, 23 1/3, and 36. Our next test will be 4 files of sizes 50, 54, 28, and 78, and expected outputs of 2, 52.5, and 78. And our final test will be 5 files with sizes 38, 124, 36, 49, and 110, with expected outputs of 2 files larger than 50 megabytes, the average of 71.4, and the largest file size entered of 124. Now we can test our algorithm against a server to verify its accuracy. Doing so, we see that we passed all test cases and we conclude that our algorithm is correct.